maximization in the long run. And so remember here, let's assume there are two inputs and they're both variable. They have to be because it's the long run, right? And we're going to assume the prices are W1 and W2, just like before. The price of the output is P, and the production function is F of X1, X2. So now the maximization problem is they want to maximize P, F of X1, X2, minus the cost of input 1 minus the cost of input 2. And now X2, notice there's no bar on it because it's not fixed. And we get to pick X1 and X2 that does this. Well, this is just a maximization problem. We're going to have two first order conditions that are going to have to be equal to 0, right? So if we take the derivative with respect to x1, again, we're going to get, just like before, P times the marginal product of good 1, x1 star, x2 star, minus W1 equals 0. So this is the first order condition. The second is with respect to x2. So the derivative of this with respect to x2 is price times the marginal product of good 2 at x1 star, x2 star, minus W equals 0. Well, we could kind of rearrange this. We could move W2, to be quite clear. We could kind of move these W's to the other side. And we get this, right? So here are two equations and two unknowns. There's two equations and two unknowns, and we could solve for x1 and x2 star as a function of P and the price of output P, and as the price of these two inputs. So we can as a function of P, W1, and W2, and call this the factor demand functions. So, kind of algebraically, it's going to be like x1 star, W1, W2, P, and x2 star, W1, W2, P. So here are kind of our factor demand functions, kind of like demand functions we saw before, right? Instead of putting actual input prices in and the price of output, kind of solve them generally. Now what we're going to do in terms of those practice problems we're doing this week is we're going to actually actually solve for this with functional forms for this production function, so we can kind of practice what that looks like solving, as well as for like the short run one as well. So that's what we're going to do in terms of practice, just because you see the theory here, but it's a bit different when you try to apply the theory, right? It's kind of hard to do that. Okay, so that's kind of how we think or how we approach profit maximization in the long run. We just have this maximization, this objective criteria. At the maximum, the partial derivative of this with respect to x1 equals 0, as well as the partial with respect to x2 equals 0, and use the same kind of interpretations as we had before, right? This first one is kind of exactly the same as we got before. Now we just have a second one as well. We have two equations, these two first order conditions, and we have two unknowns, x1 and x2 star. And we just got to rearrange our equations that we would get. So x1 is a function of price, W1 and W2. And we're going to get some kind of general factor demand functions, which we had. If we had different input prices or price of outputs, we could put those in and see how much of each of the input we use. There are demand functions, which are very similar to like the demand functions that we saw when we had consumer maximization kind of problems or consumer theory. You remember we also talked about like the inverse demand function for different products in consumer maximization. We can talk about the inverse factor demand functions when we talk about producer theory. So under our factor demand functions, kind of were of these forms where it's like the optimal amount of input one. So remember, x1 is the amount of input one now, which is a function of the price of output, so the price of the product we're selling, and then the two input prices. So consumer theory, remember, it was like M was the budget, and we had the price of good one, the price of good two. Same kind of idea. Then we have x2 star, which is a function of the same thing. So it's the optimal amount of each of these inputs to use in our production process when we're maximizing profit. Those are the ones that satisfy those two first order conditions that we just talked about. Now, we can, if we have these equations, we could rearrange them, and so we can express the price of the input, so W1 as a function of the marginal product of factor one, as well as the price of output, and do the same thing for factor two. So let's kind of, maybe that wasn't clear, so let's write that out. The inverse factor demand measures what factor prices must be in order to in order for some quantity to be used, for some quantity to be used. And maybe when I draw the diagram, that'll be somewhat clearer. So you can think about, like, we're thinking about W1 equaling something. So in the example, or like the general case that we kind of saw, it was like W1 equals the price times the marginal product of input one at x1 star and x2 star. Actually, I'm going to take the star off because we want this, we're going to vary the amount of the input here. And so if we were to draw that out, they'd start to look like demand functions for this good. And so this is like W1, or the price of input one. This is the amount we're using. And then we're going to draw this function out. And so it might look something like this, where it's P at the marginal product, x1 and x2 star, or like the optimal amount of good two, like input two. And what we're doing is we're like varying the amount of input one we're seeing, and we're seeing what the price of that input must be in order for us to want that much. So it's like, well, let's say, in order for us to want x1, let's just call prime, amount of input one, we wanted to have that much optimally, then this is what the cost of that input would need to be for us to want this much of that input. And it's kind of showing that relationship. So it's kind of like those demand functions and then the inverse demand function. Remember, it was like the demand functions kind of look like this, where the amount of each of the goods we want was a function of income, and the price of each of the goods. And then we kind of reversed that and thought about price as a function of how much of these goods we wanted, and we wrote those inverse demand functions out. It's the same idea here. Okay, So that's what kind of inverse factor demand functions kind of look like. Inverse factor function, inverse factor demand looks like these kind of demand curves for this factor.